Hi everyone, let me know if the sound is working. And then we can get started on today's paper, which is November 2019, paper 1, obviously higher tier. Perfect. Okay, the other thing that I put up a poll this morning about a predicted paper which I've written, and most people have voted to go through it in the live this week. So I'm going to do that tomorrow. Okay, so tomorrow's live at 7 o'clock, same time. That one will be now the paper 1 higher tier predicted paper for Edexcel. So we'll go through that tomorrow. I'm also making a video on it, which will be, properly edited and everything. That will upload on Monday anyway. So let's jump into this paper. If at any point you have any questions, just leave them down below in the chat and I will try to respond. So question 1, super common for non-calculated paper, is either lowest common multiple, highest common factor, sometimes both, or just sometimes the product of prime factors. Yeah, so the next Q&A will be tomorrow at around 5 o'clock, before the predicted paper, so we can have a look. If you've sent me one, we can have a look tomorrow in the Q&A session. Yes. Okay. So find the lowest common multiple of 108 and 120. So you can do this kind of two different ways. If you want to write down the times tables of both these numbers, you can do that until they overlap. But I find that because they're such big numbers, and we obviously don't know the times tables of 108 and 120, that's a little bit harder. So what I tend to do is use the prime factor trees and then the Venn diagram. So I'm going to split it. First of all, I normally, if it's an even number, I'll just start with 2 basically. So split that in half and keep doing half until it's no longer even. Okay, so now it's odd. I'll either check 3 or 5. So 3 obviously goes in to 27, and then 3 and 3. And then 120, again, just starting with 2. You start with any number, but I just like to keep halving it until I can't anymore. 5 and 3. So then I just scribble out some circles. You obviously don't have to do it accurately at all, but I might as well get a nice circle here. So one side will be 108, one side will be 120. Now, I do the overlap first, so whatever they have in common, I'll write it down once. So for example, there's a pair of 2s here. They both have 2, so I'm going to put that once. And then they both have another pair of 2s, so I'll put that again. Then there's no more 2s. They both then have 3. And then that's it in terms of the middle. Everything else just goes on the left or the right. So 3 and 3 for 108, and then 2 and 5 for 120. So once you've done that, the lowest common multiple, you just have to remember I need to basically multiply the whole Venn diagram. The whole Venn diagram. So 3 times 3. You can obviously do this in whichever order you want to multiply it in, however you find it easier. So I think I would probably go, well, that's 18, times it by 2 again, 36. Over here that makes 10, and then a 3. So this one times by 3 would be 90 plus 18, 108. 108, and then times by 10 is quite easy, so we should get 1080. I think, yeah, 540 is half of that, isn't it? Yeah, so if we double that, yeah, 1080 is what we should get. Exactly. So yeah, you can multiply that in whichever order makes sense for you to multiply it. As long as you get 1080 at the end, then that's fine. 3 marks there. Okay, now we've got some ratio by the looks of it. So there are 60 people in a choir. Half of the people in the choir are women. So I kind of already started just making some notes in this case. That's 30, isn't it? The number of women in the choir is 3 times the number of men. So I just divided that by 3, which is 10. And then the rest of the people in the choir are children. So then the children, because it has to add up to 60, doesn't it, would be 20, because that's 40 and 20. Then they've said the number of the children in the choir to the number of men in the choir is n to 1. We need to find the value of n. So first of all, I've just put this in a ratio of the children to the men. 20 to 10 is the literal figures. Obviously, if we simplify that, do you see how they've got 1 on the side of the men? But luckily, this does simplify quite nicely. Divide by 10 on both sides, we get 2 to 1. So in this case, n is the 2. How do I get 30? So do you see how it says here, there are 60 people in total, half of the people are women. So half of 60 is, that's where I got the 30 from. Just from that like second sentence there. And then I just pieced it together as we went through, basically. So this is kind of just, you know, a bit of ratio, a bit of kind of general arithmetic is what I'd class this as, I guess, just working out, you know, interpreting the wording into maths. Okay, so 2 should be the answer there. Number 3, this, I feel like 90%, 99% of the time comes up, some form of fractions operations. It could be multiply, divide, add, subtract, any of those, but it's normally with mixed numbers. So when we're multiplying and dividing, you would have to convert the mixed numbers into improper fractions in order to then multiply or divide. When you're adding and subtracting, it doesn't really matter if you do or don't, but I find it's easier just to stay consistent with the same method. So I normally always convert mixed numbers into improper fractions anyway. So you would do the whole number times the denominator, so that's 1 times 4 is 4, obviously, and then add the 3, so that'd be 7 quarters. Multiply by 1 times 3 is 3 plus 1 is 4 thirds. And then obviously multiply, and we just go straight across, don't we? So the top, the numerator would be 7 times 4, which is 28. And then 4 times 3 is 12 in the denominator. Now, they've said give your answers a mixed number. I would probably also simplify it. You can either simplify it now and then convert it into a mixed number at the end, or you can convert it into a mixed number now and then simplify it at the end. It doesn't really matter which order you do that in. This obviously, they're both divisible by 4, aren't they? So I'd get 7 over 3 and then convert it into a mixed number. So how many 3's go into 7? 2 whole ones, but then I've got a remainder of 1. So yeah, as you said, 2 and 1/3, exactly. That's what I would do, 2 and 1/3. So 3 marks there. Now, the interesting thing about this one, though, they didn't say to simplify it. So technically, they've said obviously 2 and 1/3 is the main answer, but they have said any equivalent mixed number. So like if you just converted this into a mixed number, which would have been 2 and then what, 4/12. If you left it like that, they would also accept it. Just double check the question, because sometimes they do say you need to simplify it, sometimes they don't. I normally just naturally simplify it anyway, just to be safe. Okay, question 4, we've now got some construction. So use a ruler and compasses to construct the line from the point P, a line from point P perpendicular to the line CD. And you must obviously don't rub anything out. Now, obviously I don't have here like a compass, so I'm just going to kind of roughly try and show you. I think there's a few different ways to do this. The way that I did it is because basically the main issue is that P's not in the center, is it? If it was in the center, you could just kind of stretch from C to, you know, beyond halfway, do an arc, and then do the same width from D. Obviously, in this case, P is not in the center, it's off center. So I think what I did was I just started at D, because that's the shorter side. I stretched my compass so it's at least beyond point P, right? So maybe about this width, right? And I did kind of, well, yeah, I made sure it crossed through P right up here. It would probably come to about here in the line, and then, you know, down here as well. You can do a whole arc if you want. And then from that, I'd kept my compass the same width, so I didn't change my compass. I then put it on this point on the line, and then did the same in the opposite direction, so it crosses here, obviously, you know, again, roughly here, and then here. And then I drew a line, you know, straight line with my ruler, joining up these two kind of crosses. Now, Obviously mine's not accurate because I haven't used a compass in digitally, but when I did it on a piece of paper, it did work out. I know that some people like to do some kind of measurement. They like to measure a distance here and then get the same distance on the other side. You could, you know, measure it if you wanted to, but effectively it's just making sure that you've got your compass kind of at an equal distance from both directions. And obviously with point P in the middle of that. So then I would obviously get a straight line. You would just draw a straight line. And you would cross through like these two. Now, as you can see, mine's obviously not straight because I've not used an actual compass, but yours, you know, would be straight if you've done it on a piece of paper correctly. So yeah, don't rub anything out. You might have drawn the whole arc, that's fine. But yeah, we're basically just drawing a perpendicular line. Okay, construction doesn't often come up anyway, this one actually. Construction is not a super common topic, but obviously you just never know, do you? It could come up. Okay, question 5, we normally get some kind of just general angles question, maybe a bit of ratio within that. So we've got, the diagram shows triangle ABC, so the whole thing. ADB is a straight line. I think that's kind of implied, isn't it? The size of angle DCB, D to C to B, so this one, to the size of the angle ACD, so this little one here, is in 2 to 1. So if you wanted to, you can either use a ratio, or sometimes I just put it as like the smallest one is X, and then obviously the other one would have to be 2X, wouldn't it? I sometimes do that. You don't have to. It's up to you, just to kind of keep that information there. Now it says to work out the size of angle BDC. BDC. So this one, we get a different colour. This is the one we actually want. Okay, so we've kind of got a small triangle and then a bigger triangle. What I'm thinking is, if I look at the bigger triangle, I have 2 of the corners, 2 of the angles. And then I'm missing this one, aren't I? So I would just go, right, okay, obviously this angle as a whole, ACB, would be the 180 degrees in a triangle minus the other 2, 51 plus 75. So you'd work that out, what's that, 120, 126, and then take that away, 120, if I take away 120, 60, 54. Yeah, exactly, you said 54. So that whole thing's 54. Now, I've obviously used algebra. You can just then you know, share out the ratio if you want to. Either way, we need to divide 54 by 3, don't we? So whether you do it because of the ratio, whether you do it because of thinking about the fact that it's 3x, it doesn't matter which logic you use as long as you divide by 3. And I'm pretty sure that gives us 18. So obviously the top one's 18, but then actually the one that I want, because now I want to focus on the smaller triangle, this one here with the pink angle, so I want the 2x, don't I? 2x would be obviously then 36. So now I know that that's 36, and then my actual final answer, we can work out, what was it called, BDC, that angle, is obviously then another triangle, isn't it, 180 minus the 51 and the 36, which that gives me 87, so yeah, 93, those of you who've written 93, that's perfect, exactly, you should get 93. And it's actually 4 marks, that's quite a nice one for 4 marks, 93. As long as you get 93, if you've done it in a different kind of way, to me that's fine, as long as your answer is 93, then it will, you know, technically be mathematically correct. Okay, question 6, we've got some kind of mean question now. So, 4 red bricks have a mean weight of 5 kilos, 5 blue bricks have a mean weight of 9 kilos, and 1 green brick has a weight of 6 kilos. Donna says the mean weight of the 10 bricks is less than 7 kilos. Obviously this adds up to 10, doesn't it? Is Donna correct? So we want to know the mean weight of all of them. Now, this is what in my head, I call it reversing the mean. The way that I would do it is I would work out the total weight of the red, total weight of the blue, obviously the green is just 6, and add those together. So when I say reverse the mean, normally when you do the mean, you add them all up and then divide by how many there are. Now, in this case, we know how many there are, and we know the mean. So if I just, instead of dividing, if I then multiply, that's the opposite, isn't it? So for example, the red, obviously I can't figure out what they all weigh individually, but I can work out what they all weigh in total, can't I? So I would just do 4 bricks times by each of them have a mean weight of 5. That means that all 4 bricks in total weigh 20 kilos. I don't know how that was split up between the 4 bricks, but that doesn't really matter. So then I would do that for obviously, well, technically just the blue, because the green is already just 1 brick anyway, isn't it? So blue total is 5 bricks. They have a mean weight each of 9, so 5 times 9 is 45. Obviously the green was just 1 brick, so that was 6 kilos. So then I can just add that. Now I can find the total weight of all 10. So that's like the total of 10 bricks. So what's that? 65, 71. And then obviously now you're just finding the mean, aren't you? The mean is just, as we said, add them all together. So that's 71, divide by how many there are, 10. That's quite an easy thing to divide, isn't it, that one? Just move the decimal place once. 7.1 kilos. Now, we do actually then have to kind of suggest if Donna was correct or not. The mean weight of the 10 bricks is less than 7 kilos. Well, no, because I've got 7.1, which is obviously more. Yes, exactly. Yep, all your working is correct in the comments, yeah. So it's just reversing the mean. You just multiply instead of dividing to find originally what they all added up to. Okay, question 7. There's always some kind of indices, index laws, that kind of thing, isn't there, with non-calculator? So these should be quite easy marks. When we've got the brackets, it basically means we're multiplying the powers, so that would be p to the power of 10. And then the second one, a little bit more complicated, but just work through it in 3 stages. Now the 12 and the 6 are not powers. They're not indices, are they? They're just numbers. So in that case, you would just divide those as normal numbers, so you get 2. But then, when we then look at, if I highlight it, the x, and then obviously you've got separately to that, the y's, that's then when our index laws are coming in, isn't it? So x to the power 7 divided by x to the power 3, obviously that's when I subtract the powers, so that would be x to the power 4. And then the y one, don't forget though, because this is technically a 1, isn't it? So when I subtract 3 and 1, I get 2. Yep, so 2 to the power of 2, and then x to the power 4 y squared is what you should get. Why do I multiply? That's just what the rule is for part A. I'm assuming that's what you mean. That's just the law, the index law. There's 3 index laws, right? We've used the second one here. That's technically the third one. Because effectively, I mean, I can explain it. It's kind of like saying p squared times p, like 5 times, isn't it? That's effectively what that's saying. And now in terms of when you've got a multiply symbol like this, that's when you add them, isn't it? See how that would also make 10? Oh, the previous question, sorry. Why do I multiply them? Because I'm reversing the mean. So if I were to write it out fully, you would, let's say you wanted to work out the mean. I know it's 5, but let's say you wanted to work out the mean of the red bricks. You would do the total of the red bricks, wouldn't you? You'd add them all together if you knew what they were. You would have added them all together. You would have divided by how many there are. And do you see how that would give me 5? So if I set up that equation, do you see how, think about it as an equation. If I want to find the total weight of all the red bricks, do you see that's why I would multiply by 4? Like I would, if you're thinking of solving an equation, you would multiply by 4, wouldn't you, to move it across? So it's like, in my head, I could think of it as like I'm undoing the mean. I'm kind of reversing the mean, because that will give me the total weight, yeah, of all of the red brick, and the same for obviously the blue. I didn't do it for the green, because obviously the green, there was only 1 brick anyway. So you didn't need to do it for that. But yeah, you can always reverse the mean, like as in undo the mean, if you, however you want to word it. That's how I think of it. Yep, so that was 7 as well. Question 8. This one is bearings and scale, and this one actually you have to physically measure, which obviously mine isn't to scale, so I don't know if you've got it printed in front of you A4 size, then it I would assume would be the correct scale. If you've printed it kind of 2 pages on one, it won't be the right scale, but we can at least talk through, you know, the steps. So the accurate scale drawing shows the positions of port P and then a lighthouse. They've obviously given us a scale, so 1 centimetre in real life, like if you've printed it as a full A4 sheet, 1 centimetre would represent 4 kilometres. So Alina sails her boat from port P on a bearing of 70 degrees. She sails for 1.5 hours at an average speed of 12 kilometres per hour to a port Q, which is obviously not drawn there. And then in this question, kind of 2 in 1, we need to find not only the distance in kilometres of port Q from the lighthouse, not from P, but from the lighthouse, but also the bearing of port Q from the lighthouse. So what you would do first is you would get your protractor, right? And you'd measure 70 degrees. Now, obviously I don't have a protractor, but roughly, right? I mean, if that's 90, I'm going to say that 70, let's say that 70 is kind of I don't know, let's say 70 is like that, right? Let's say that you measure 70. With bearings, we're always measuring from the north line. So in this case, because it was from port P, the north line of port P clockwise. So in this direction. So let's just say that that was 70 degrees. You would obviously measure it yourself accurately. And we don't really know currently how far she went, so I'm just drawing the line that far. Now, as you've put in the comments about working out now, this bit here, how far does she actually sail along that line? So you want to work that out. Speed, distance, time. We're looking for the distance, cross that out. So it's speed times time. The only thing to be aware of is that they've put 1.5 in terms of a fraction. Obviously, we would use like 1.5 as you've done. Yeah, you have to use a protractor because otherwise where would we get 70 from? That's the other thing, isn't it? But yeah, the thing you said before was correct. So obviously I'm going to use 1.5 as my time because it needs to be in hours, multiplied by 12 in kilometers. So that's just like, if you get 50% of 12 and add it on, that would give you 18. However you want to calculate that. 18 kilometers. Not kilometers per hour, 18 kilometers. So obviously that's in kilometers. We would then need to convert that into our scale, wouldn't we? So they've said that 1 centimeter represents 4 kilometers. So now, in order to be able to measure it on my centimeter ruler, I would need to obviously convert it back. So normally I should kind of write that there. If that's 4 kilometers, how many centimeters? I'd obviously need to divide, wouldn't I? 18 divided by 4. So you can divide by 4, or you can also just half it and half it again. Either way, you should get 4.5 centimeters. So in real life, again, if you've printed it at the correct size, you could then get your ruler and measure from the point P 4.5 centimeters along that 70 degree line. Now, I think from when I saw someone do it that actually had the proper scale, I'm pretty sure it was kind of, let's say roughly about here. It was roughly about there. So that would be the location of Q. Now, we haven't still answered any of the questions yet. So they've said, work out the distance in kilometers from Q to the lighthouse. And now I'm obviously going to either draw a line or obviously get your ruler and just measure it from your point Q to the lighthouse. How far is that? Now, obviously they've given a slight range. I think you should have got somewhere around 5 centimeters, maybe 5.5 centimeters, something about that you would have got. So let's say that we got 5.5. Let's say that I measured that and I got 5.5 centimeters. Obviously, I then need to put it in kilometers, don't I? I need to use the scale backwards again. So in that case, because I'm going the other way, I'm just going to multiply that by 4, aren't I? So for I, it would be 4 times whatever you measured it as. Again, as I said, something between kind of 5, 5.6, 5.7, something like that. So double it again, so that'd be 1122 kilometers. Now, they have said that the range is that as long as you got between 20 and 23 kilometers, that's the range. No, you got 27. So they wouldn't have given you, I don't know if you printed it like the size that they would have, officially the exams have printed at. Technically, it should be between 20 and 23, but I'm assuming as long as the steps are correct, we can kind of assume that maybe the scale of the print just was different. Yeah. So that was part I even. And then the bearing of port Q from the lighthouse, this is what we need to know. Well, what angle is that referring to? So it's always kind of backwards, really. It's from the lighthouse. So from here, from this point, and obviously from the north line, always clockwise until you hit the line between, in this case, the lighthouse and port Q. So that would be this angle here, wouldn't it? You see that? That'd be that angle there. Now, what you can do is either measure that, or if you want to, because you might only have the 180 degree protractor, you could measure this and then subtract it from 360. Why did I divide by 4? Because that's the scale. Because they've said 1 centimeter represents 4 kilometers. So how many centimeters would 18 represent? Yeah, you'd have to. It's just applying the scale. I'd have to divide by 4. Do you see how 18 divided by 4 would give me 1 centimeter? Well, would give me it in centimeters, which was 4.5. Or if you did 4.5 times 4 kilometers, you'd get back to 18, wouldn't you? So it's just applying the scale, and then over here I've obviously applied it backwards because I was actually given something in centimeters to convert back into kilometers, so I had to multiply in that case. Currently I don't do any tutoring, sorry, I just do the lives here, but you can always ask obviously questions. on the lives and leave comments on my videos, and I'll get back to you. So you would have measured it, as long as you got something. They've given a range for this. Obviously I don't have a protractor either, but they've given a range. As long as you got, however you chose to figure it out, something between 317 and 330, so a fairly decent range they've given you there, that would be fine for your bearing. But obviously you have to just make sure you know which bearing it's referring to. Okay, so 316, yeah, I mean, I can see that you're within, you know, roughly the right, you're in the ballpark. It's probably just how it printed as to how accurate it is. So those are our two answers, either something between 20 and 23 kilometers and something between 317 and 330 degrees, okay? So a bit of speed, distance, time, and then a bit of obviously bearings, measuring, scale, all of that into one question. That's, I guess, why it's 5 marks. Okay, we've also got question 9, speed, distance, time again. So a car travels for 18 minutes at an average speed of 72 kilometers per hour. You can see here there's already a discrepancy in terms of the time. How far will the car travel in these 18 minutes? So we're looking for a distance. So we know that we would have to do speed times time. However, as I said, there is a discrepancy in terms of the units of time. You have to make sure that it matches. So we've got the speed, that's fine, 72, but I'd need to convert the 18 into hours. So if you want to convert any minutes into hours, you divide by 60. They've obviously chosen 18 deliberately because it's, you know, there's multiples of 3, 6, and so on here. So is 60. So I'd probably, I mean, however you want to work it out, I'd probably simplify that fraction, so that would give me 3/10. So it's effectively saying 30% of 72, isn't it? Divide by 10 times by 3, again, however you want to work it out. So dividing by 10 would give me 7.2. 7.2 times 3, I normally just kind of add it up, so that's 21.6, isn't it? Okay, 21.6. Yeah, exactly, you're right, you're both right. 21.6. Okay, so just be careful with this. And it's also the same for, you know, when you have like density, mass, and volume, making sure that all of those units match up. It's the same kind of logic. Whenever you've got this formula triangle type, you have to make sure that the units do match before you start using the triangle. Okay, then we've got part B. So David says 72 kilometers per hour is faster than 20 meters per second. Is David correct? Obviously, we need to actually show how we get there. What, the 108/5? I'll check the mark scheme. Because it's technically equivalent, isn't it? But let me check the mark scheme. It's question 9, isn't it? They've said 21.6 or equivalent, so I would imagine, yes, I would imagine they would allow that because that is the exact equivalent, isn't it? Yeah, I think they would allow that. I would be more inclined to try and work it out, but yeah, it says or equivalent, so yeah, I think that would be fine. Okay, in this case, we obviously want to convert one to then match the other. It doesn't really matter which way around you convert it. Yeah, so you've converted it into meters per second. I think I converted it the other way. I think it's up to you really, but I think I converted the meters per second into kilometers to then compare the 72. So what I did was I said, right, 20 meters per second. So we've got 20 meters per second. I then said, well, what would that be per minute? How many meters would that be per minute? So I did, okay, well, that'd be times 60. Obviously, that's 12 plus 2 zeros. So that's 1,200 meters per minute. I just broke it down. You don't have to break it down this much if you don't want to. Then I went, right, okay, how many meters is that in an hour? Again, times 60 again. So you get 72 plus 3 zeros. That's a meters per hour. And then obviously then I converted it into kilometers to divide by 1,000. So 20 meters per second is actually exactly the same as 72 kilometers per hour. So he said 72 kilometers per hour is faster Is that correct? Well, no, it's not technically faster, it's the same, isn't it? That's how I did it. I think you could convert the 72 kilometers per hour into meters per second if you wanted. Just in my head, that felt, I don't know, in my head that felt harder, so I just didn't do it that way. But if that makes more sense to you, that's fine. Yeah, exactly. It is exactly the same. Yeah, exactly. Yeah, so you did it the other way. You divided it, which is fine. Yeah, yeah. So as long as you've done anything where your answer is obviously the fact that they're the same and you've literally compared them, then it doesn't matter if you did it my way or if you did it your way, which you converted the other way. That's fine as well. Either way, the answer is no, because they are the same. Okay, cumulative frequency, for some reason in Edexcel, cumulative frequency comes up all the time in non-calculator. I mean, it could come up in calculator, but I feel like I've seen it so much in non-calculator. So the cumulative frequency table shows information about the times in minutes taken by 40 people to complete a puzzle. Okay, so you see they've already done the cumulative frequency table for you. Sometimes they ask you to fill out that table yourself, but in this case they've already done it. So straight into part A, on the grid below, draw the table. That's draw the graph for this table, basically. So all you need to know is we're going to be plotting the right-hand side in terms of this range bit. You want to plot the right-hand side. Okay, so obviously at 40, this one's, just be careful because you know how the graph, they've got 20 here. That normally that's the first point, isn't it? But no, in this case they're starting at 40, so just be careful of that and just double check scale. So that's 5. Then at 60 you're at 25, just here, and then 80 you're at 35, 38, which is there, and then 40 is obviously for the 120. Obviously try and join that up. 20, 40 goes 5 squares. It's not the midpoints, no. The midpoint is when you work out the midpoint, that's for a different topic. It sounds very similar. That is for frequency polygons. So it does sound very similar. They both have the word frequency in it. It's a very similar table, isn't it? That's when you do the frequency polygons and you do kind of like straight lines and you join it up and it's kind of jaggedy like that. It looks a bit like that. So that's for frequency polygons. This is a different topic. You always do the right-hand side. Always do the right-hand side. Yeah, frequency polygons. Yeah, histogram is like, it's kind of like a bar, isn't it? Whereas cumulative frequency, in terms of the graph, is like a nice curve. Now, normally I start from 0, but because we don't have the 20 like point, I think I would just probably leave it and I would start from 40 because like this is going to look really weird, isn't it, if you do that? I would leave that. So in this case, I would start here. I'm going to try my best. Oh, that's horrible. Let me try again. Obviously, in pencil, you do a much better job in real life than I can do digitally. But, you know, try and just join them up as smoothly as you can. The reason being is because for part B, sometimes it's part C, you have to use the graph. No, for a frequency polygon, you have to leave it open, which I know sounds counterproductive. What's the word? Yeah, counterproductive. It sounds like counterintuitive because you're like, well, that doesn't make a polygon. But yeah, you have to leave it open. You don't join it up. For a frequency polygon, you leave it open. Yeah. I don't know why they call it a polygon based on that. But anyway, so you'll get some kind of curve. Now, obviously, cumulative frequency graphs, because every time you're adding more, it should always increase. Like obviously a frequency polygon goes up and down. In terms of a cumulative frequency graph, it will always go up. So if your graph comes down again, something is not right. Yeah, I've seen on the mark scheme you're not supposed to make a polygon, but it doesn't even come up that often. But if we did find a question, I have a question, so I can check the mark scheme. Or they might say ignore if they've joined it up. I don't know. I have to check the mark scheme again, see how specific, like, you know, how fussy they are about it. Might depend on different exam boards as well. Maybe other exam boards would be okay with it. I guess it depends. Let me see if I've got a question really quick. I don't know. Don't know if I have because it's such a small topic. Hang on, I don't know which. Just check which topic it's under. Frequency polygons, there we go. I'll just try and find a mark scheme. Oh yes, you get given a frequency table, obviously, frequency polygon. Okay. I'm going to copy just the mark scheme, right? Just really quick. It's going to let me paste it. That doesn't let me paste it. Okay, I'll just bring this over. What is it doing? Yeah. Here. So part A was some other question, right? Part B is then draw the frequency polygon. So if we have a look, line segments, so they mean like, you know, joining up with a ruler for all of those points. Now that's the midpoint. You see 130 to 140, they've said 135. That's where you do the midpoints. So you get 2 marks for a fully correct frequency polygon, for points plotted correctly at midpoints of intervals, or for joining the points with line segments at the correct heights and consistent with the intervals. Does it say anything about joining it up? I don't know if this one says anything. Correct frequency polygon with 1 point incorrect. Oh yeah, that's if you only get 1 mark, right? Ignore any histogram drawn and any part of frequency polygon outside the range. No, that one doesn't say it. Let me find another one. Pretty sure there was one where it mentioned it. Yeah, that's another one, frequency polygon. Let's see. Does it say? It doesn't say anything, does it? Ignore any histogram or any part of the frequency. Yeah, that's the same thing as said before, isn't it? Joining must be line segments. You have to kind of do straight lines between each of them. For correct frequency polygon. I thought it had said something about it. Oh, here, is it this one? Here. So do you see here you get 2 marks for the actual question was 2 marks, but then this B1, all of this list here is for if you, any of this is obviously slightly wrong, they'll only give you 1 mark. So this last option says, correct frequency polygon with first and last points joined directly. That will only give you 1 mark. That's saying if you join it up and create like an actual polygon, right? They're saying you'd only get 1 mark in that case. So I guess it depends, but yeah, in this one they've specifically said not to join it up. And then do you see here they've actually drawn one, write down 2 things that are wrong with it. Let's see what they've said is wrong with it, because you see they've actually joined it up. They've said, well, there's no frequency label, that's fine. The polygon should not be closed. You see here, one of the options for saying what's wrong with it, the polygon should not be closed. It shouldn't have a line at the bottom, have the first and line points connected. So yeah, they're saying that it's wrong to join it up in Edexcel. I don't know if other exam boards might say something different, maybe, but in Edexcel they're saying that, yeah, they're saying that you shouldn't join up a frequency polygon, okay? Frequency polygons, yeah, it looks like it's about 2 marks for drawing it. Might have other questions related, but in terms of drawing it, it looks to be about 2 marks. Yeah, in terms of just spending time, I think obviously it's 80 marks, there's 90 minutes, right? So you've effectively got a minute per mark plus 10 minutes at the end. That's kind of, you know, obviously that's not perfectly gonna end up spreading out like that. Some of them you'll do faster, some of them you'll do slower. But sometimes what I think is if there's a question that I'm not really sure about, or a question that I'm taking, you know, I feel like I'm gonna take a long amount of time on, is I'll look how many marks it is and I'll kind of look at the clock. You know, there'll always be a clock in your exam hall, or if you've got a watch or whatever, and I will say, do you know what, I'm going to give myself this amount of time, and I'll just, if I get to that amount of time and I'm not even, you know, if you're going to finish in like 1 minute, then finish it, but if I'm not, then I'll just be like, move on. Or if there's a question I'm maybe not sure about, I might just keep moving. Sometimes I just think it's better just keep moving, answer the questions you already know how to answer, and then you can always come back at the end, but at least then you've given yourself time to see all of the questions in the first place and not miss out the last few just because you ran out of time. But yeah, it's just practice. It's practice. Keep looking at the clock in the exam hall and just, yeah, try and, as you said, not spend too long on one of the questions, because you might then be able to do another question with more marks at the end. You just don't know. Okay, I think there was a part, yeah, part B and a part C. Use your graph to find an estimate for the interquartile range. So you need to know how to do interquartile range. and median. It's kind of the same logic, isn't it? The interquartile range, you obviously need to know, is the upper quartile minus the lower quartile. The upper quartile is, you can either think of it as 75% or 3/4. Lower quartile is 25% or 1/4 of the y-axis. Median is the same. Median is the 50%, the middle of the y-axis. Now, the total was 40, wasn't it? Remember from our table, it was 40. So I'm thinking, what is 1/4 and what is 3/4 of 40? And then I'll draw lines across there. So, for example, the lower quartile is, you don't have to write this, I'm just kind of over-explaining it, 25% or 1/4 of 40, which is obviously 10. So that's, in this case, what was the context? I can't even remember what the context was. Oh, people, yeah. Sometimes it's plants or things like that. So that's the 10 is not the lower quartile, right? The 10th person. So that's why we're looking at the frequency side. So at 10, draw a line across. Obviously, get your ruler, do this. Now, they will give a slight range of possible answers because obviously, even though your coordinates on the graph should be the same, your curve, you know, it's not like everyone's going to draw exactly the same curve, is it? That's quite difficult. So when I read mine off, it gives me, just be careful of the scale, right? Because that's not 43. This is 50, so that would be 46 in my one. Yours might be slightly different, that's fine, as long as it's somewhere similar. I got 46. So in terms of my lower quartile, that's minutes now, isn't it? Minutes. Now I do the same for the upper quartile. Obviously that's then 75% or 3/4. So whatever 1/4 is, just times it by 3. So that would be my 30th person. So then I obviously draw, let's just do the same thing from here. It's just repetitive, isn't it? Draw a line at 30. Mine goes kind of halfway through, I think, there. And then obviously down. I think I would go with maybe 69. Again, you might have a slightly different number than me, that's fine. Oh, what is that? 69 minutes. Now, I've got both of those, so let's go back. 69, 46, 69 minus 46. I obviously have to then subtract them, right? So what's that? 29, take away 23? 23-ish. You got 24, exactly. Yeah, we're very similar. I think when I did it on a piece of paper, because I've done it on a piece of paper before, I got 22, I got 23 this time, you got 24. They've said as long as you get something between 21 and 28, so it's quite a big range, then they will allow it. So 24 is absolutely fine. They will accept that. Sorry, the person asking about tutoring, I don't do tutoring at the moment. I think I answered that earlier. So it would just be these lives, but you can obviously feel free to ask me any questions on these lives, and I'll try and get back to you. So that's that. If you do the median, same exact process, but obviously you would look at the 50% mark, which is like halfway. So that would be technically a 20 across. And then now sometimes they then ask you another question, but then it's, you see how in the first one, part B, we did from the y-axis across and down. Sometimes there's also a question from the x-axis, you draw up and across. So it can be kind of both ways. So one of the 40 people is chosen at random. Use your graph to find an estimate for the probability that this person took between 50 minutes and 90 minutes. So do you see how that's now in terms of minutes? So if I come back, 50 to 90, that's now from the x-axis. So let me get a different colour. So obviously I'm going to go at 50. Again, be careful of the scale. 50 is here. And this time I'm going up. And then I'm going to read off of the cumulative frequency. So there, what's that? 11, 12, 13, 13 or 14, I guess. Let's call it 13 because we can't have half a person, can we? 13. And then obviously at 90, which is here, do the same thing. Up and then across. I seem to all be halfway between, but that's fine. What, 37 I got there? So the people between that is obviously I need to subtract that as well, don't I? So I got 37 and 13, so let's do that. 37 minus 13 gives me what, 24? Now, I do need to make it into a probability though. Yeah, you got 36 and 40. Yeah, exactly. Very similar to mine. So you got 22 out of 40. Yeah, that's fine. I got 24, and then as you said, put it as a probability. So that's obviously 24 people out of how many people in total? Well, there's 40. When it's probability, you don't normally have to simplify it. You can if you want, you don't have to. What was the range? The range here, as long as you got between, 19 out of 40 to 24. So I'm just about on the upper limit. Yours is bang on in the middle, so yours is probably more accurate than mine. So yeah, as long as you get something between 19 and 24, and then obviously out of 40, they will accept that. So yeah, 6 marks. I find cumulative frequency is quite a nice one. 6 marks. Okay, question 11. There are P counters in a bag. 12 of the counters are yellow. Shafiq takes at random 30 counters from the bag. 5 of these 30 counters are yellow. So obviously there's more than 30 in the actual bag, right? But he's taking kind of like a sample. Work out an estimate for like the value of P. So we've got effectively samples here, haven't we? So I just made an equation. I said, right, the 5 out of 30 is kind of like our estimated proportion that are yellow, which would be then equal to the 12 out of P for the actual scenario. That's what I did, and I just then cross-multiplied. I'm sure you could probably do it different ways. Circle theorems, yeah, I have a video on circle theorems. I have 2 videos. I have one video where it just goes through like the 8 circle theorems, and then I have a second video which is where I've kind of tried to make up my own questions, and then you can practice applying them. So yeah, have a look. I can see if I can link it as well, but it's on my channel. If you go through the higher tier playlist, or if you just have a look on my channel, I have got 2 videos on circle theorems. I used to tutor. That's why I've now done this. But I am no longer tutoring in order to kind of actually do the lives instead, if that makes sense. But yeah, thanks. Hopefully this is clear enough, making more sense. So yeah, I just basically made this equation, cross multiply. So times by 30 times by P to cross them over. So I got 5P is equal to 36 plus a 0, 360. And then divide by 5. Dividing by 5, I just divide by 10 and then double it. So that's 36, double it, 72. That's how I divide by 5. Yep, you got 72. Yeah, everyone seems to have got 72. That's good. Yeah. Perfect. Yeah, however you want to set up that equation is fine, but as long as you get 72, then that should give you the marks. Okay, question 12. We've been given a formula, so T is equal to Q over 2 plus 5. Here is Spencer's method to make Q the subject of the formula. What mistake did Spencer make in the first line of his method? So sometimes I find it hard to explain maybe what was wrong. You can always correct it. You can write down, he should have done this instead, if you found that helpful, if you find that easier. To explain what he should have done, or you can just write the correction. Normally that will give you the mark. So obviously here, what's he done? He's obviously tried to get rid of this denominator, the 2. So he's multiplied by 2, so the left-hand side is fine. The problem is that let's say if I multiply by 2 as my first step, I would have to times that by 2. Obviously that would cancel, but I would also have to times the 5 by 2. I'd have to times everything by 2. So that's the issue, is that you see how he has not multiplied the 5 times 2. He's only just done the left-hand side. So you can say any version of he didn't multiply 5 by 2, or some version of that. Yeah, it should be this, or you could even say he could, because if I were to do this myself, I'd probably subtract the 5 first. You could say he should have subtracted the 5 first. That would also work, wouldn't it? Let me have a look at the other options on the mark scheme. So obviously it's worded, so there's loads of different possibilities of how you could word it. Okay, so their examples, they've said all 3 terms should be multiplied by 2, and not just 2 of them, because he only multiplied the Q and the T, didn't he, not the 5. You could say the 5 should be multiplied by 2. You could say, you could correct it and say it should be, 2T equals Q plus 10. Like, you could write the correction. I think that would imply enough. Or as I said, you could say he should have subtracted the 5 first and then multiplied by 2. Because if he did subtract the 5 first, he probably would have multiplied it correctly after that point. That's the options that they've given. Obviously, some kind of, version of that would be acceptable. Oh, thanks. That's really nice of you to say that. Yeah, exactly. It should be 10. The last bit should be 10. So you could write that if you wanted. Any version. I know they've given you 3 lines. You don't need to fill out the 3 lines, right? It's only 1 mark. So, yeah, that's that one. Question 13, we've got some algebraic fractions now. So part A, write 5 over x plus 1 plus 2 over 3x as a single fraction in its simplest form. So obviously that just means we need to add them and then see if we can simplify it. So when we're adding fractions, just think normal fractions. I have to have a common denominator. That's the exact same for algebraic fractions. Then you think, well, how do I find a common denominator, like the lowest common multiple? When it's algebra in the denominator, I just multiply them together. Like I literally just go, I don't obviously know the lowest common denominator, but I could just multiply them. You know, if your denominator, for example, was 5 and 7, you would use 35, wouldn't you? Just multiply them together. So I just use that same logic. Just multiply the denominators together. Obviously, that means I do need to change the numerators as well. So the first one, I would multiply the denominator by 3x. So that means I also need to multiply the numerator by 3x. So 5 times 3x is 15x. And then the second one, I need to multiply the denominator by the x plus 1. That's the bit that's missing, isn't it? So again, numerator by x plus 1. I'm just going to expand it straight away. So that's 2x plus 2, isn't it? Now I can actually add them. Obviously, the numerators we add, so that'd be 17x plus 2. They haven't really said how to leave it, so you could either expand the denominator or leave it in brackets, whichever you prefer. Yeah, you've expanded it. Yeah, they would. I'm sure they'd be fine with that. They haven't really specified how to leave it, have they? As long as it is a single fraction in its simplest form. So that would be fine if you left it, as you said in the comments, if you left it like this as the denominator, same thing. So that's fine as well. It doesn't simplify, does it? Like there's no... In order to simplify this, you'd have to find a common number or common letter in all 4 terms, which there isn't. So you can't simplify it any further. So that would just be your answer. So 13b, this one I feel like was kind of maybe a little bit tricky. I don't know. I found this one, at least in my head, I thought this was a little bit odd. So yeah, factorize it. I wouldn't expand it all. Oh, I would just literally... They both have, like if you think of it as 2 terms, where's my pen gone? Like that's one term, that's another term. In terms of common factors, I just want to think about a common factor. They both have x plus y. So I just pulled out the x plus y. And then in my other bracket, well, that first bit would be another x plus y, wouldn't it? Because then that would make the squared. And then the second term is just missing the 3. So that's how I did it. Yeah, you've also written the same, exactly. That's how I it's hard because it's double brackets, but in my head I thought about it as if it was single brackets. You know when you pull out a common factor and then figure out what goes in the other bracket? The common factor just happened to be 2 terms, which obviously made it into a bracket itself. But yeah, I thought that one was kind of difficult. I don't know. It was kind of tricky to get my head around. Yeah, so you might have thought of it in terms of exactly, we all think about it in different ways, isn't it? It just depends what makes sense to you, doesn't it? Yeah, exactly. That might have made more sense to you thinking about it as a quadratic. Yeah, I guess like when you have, let's say if it was x squared plus 3x, I don't know if that's what you mean when you pull out the x and then you have the x plus 3, but in this case the x was both terms. I don't know if that's what you mean by that. Yeah, different ways to think about it. You know, maths is not necessarily that all of us are thinking the same way. It's as long as we get the same answer, then that's fine. It doesn't matter how you thought about it. So yeah, as long as you've got x plus y at the start and then the x plus y plus 3 in the second bracket. But again, it's 1 mark. So if that one wasn't, if you weren't so sure about that one, then, we can afford to lose a mark, I think. Okay, question 14. This is quite a nice one, I think. Algebra with shapes. I quite like when they combine these 2 topics. So the diagram shows a right-angled triangle. Obviously, they've given the sides in terms of x. All the measurements are in centimeters, and the area of the triangle is 27.5 centimeters squared. So that's the context. The context is the area, therefore the context of the formula of the equation we're going to work out is the area formula. Work out the length of the shortest side. In order to find the shortest side, I need to know x. So in order to find x, I need to have an equation. That's kind of the process in my head. So the equation is obviously based on the context, which is the area. So the area of a triangle, you might know it as half base times height. You might have base times height over 2. It doesn't really matter, whichever. Obviously, it's just one of those 2 versions. So sub in, we've got, it doesn't really matter which is the base, which is the height. I guess the base could be x plus 4, height could be x minus 2, as long as you multiply those two together, it doesn't matter. Divide by 2, or if you put a half at the front, that's also fine, is equal to the area, but I actually do know the area, so I can put the 27.5 there. Now this is just an equation, isn't it? Obviously going to be quadratic, but this is just an equation. So we're just going to solve this. I pretty much multiplied by 2, just to get rid of that fraction and make this a whole number. That gives you 55. Expand the brackets. X squared minus 2x, you can obviously do this in one step if you want, but I'll write it out fully. Plus 4 minus 8, and then obviously I collected these like terms, so that makes it plus 2x, and because it's a quadratic, you have to get all the terms on one side, so I moved the 55. So take away 55, you get minus 63. Now, normally we try to factorize. If you can't factorize, you can use the quadratic formula. However, this is non-calculator, so I'm going to, opt for factorizing. So 2 brackets. One's plus, one's a minus, isn't it? X minus 2 numbers that multiply to make 63, add up to make 2, obviously one's plus, one's minus. That's going to be positive 9, negative 7. And then solve it, so x is either minus 9 or 7. Now, because we've got 2 answers, you obviously then have to choose. Yeah, you have to make a decision which one, based on the context. Normally, if it's shapes, obviously, normally you're going to disregard the negative, aren't you? I can't have a negative side length. So in this case, I'm going to go, well, it's obviously not minus 9. And I'm going to carry on with the 7. Now, the only thing to remember is that I know that you've solved the equation. It feels like that's the answer. But they did ask for the shortest side, didn't they? Now, the shortest side is obviously the x minus 2. So I now need to just, my last step, sub that in. So x minus 2, 7 minus 2 gives you 5. Don't forget to do that last step. 5 should be your answer. Let me have a look at the comments. Yeah, it can't be negative, so you have to use the 7, exactly 7, so it makes 5 at the end. If you use trial and error. I mean, I feel like it would take you too long to find the answer. I feel like that would take too long, wouldn't it? They put in the mark scheme, trial and error methods must be fully correct, identifying the value of x as 7, which will give you 3 marks, and then the shortest side, which is then 5, gives you the 4 marks. So they have said they will allow it. Obviously, just make sure you actually do get the correct numbers. So you get x as 7, you get the shortest side as 5. So yeah. Yeah, it says here in the mark scheme you can use trial and improve. I would never recommend. There's only probably 1% chance of any question in the papers to use trial and error. So I personally would normally use algebra, but that's just because I quite like algebra. So it makes more sense to me. But if you want to use trial and error, I guess you can. Let me show you. Here's the mark scheme. Can you see over here, additional guidance? Obviously, their main method is algebra, right? That's the main method. Now, obviously, you could have solved it by factorizing. As I said, you could have used the quadratic formula if you wanted. You could have done completing the square. However you want to solve it, doesn't really matter as long as you end up with the right numbers. But trial and error, trial and improve, they've called it trial and improvement. That means trial and error, right? Methods must be fully correct, identifying the value of x as 7, which will give you the 3 marks, and then the shortest side would then give you the full 4 marks. So you can use it. In my personal opinion, I wouldn't recommend it, but technically you can use it. They've said that. Yeah, they haven't said algebraically work it out, so I guess you can. So I don't know. I just feel like trial and error might take you too long, possibly. The factorizing, yeah. So, okay, so with factorizing, you're looking for two factors, two numbers that multiply to make the final number, but when you add them, they make the middle number. So it's kind of like that combo. So I'm thinking, and also the symbols, when I multiply just think about positives and negatives generally. Oh, the other one, sorry. Hang on, this one here, part B. Yeah, this is the trickier one, isn't it? So I just looked at it as I looked at it differently to someone else, but I can kind of maybe explain both. The way that I factorized it is because you see how they both have x plus y in common? Like, you see how I've split this into two terms? Look at them as two separate terms. So I said, well, they both have x plus y in common. So I kind of pulled that out as like a, you know, when you do single brackets, you pull out, like here, they pulled out 3x. 3x was the common factor. If you think about this one above, I pulled it out as a common factor. So I went, right, okay, that's the common factor. That's one bracket. I think that bit probably makes sense. It's then the second bracket. I then went, well, let me write it again. So I've pulled out that as my common factor. There's obviously then a second bracket, isn't there? In order to get from x plus y back to the first term, x plus y squared, I'm missing x plus y, aren't I? For that first term. If you see, if I multiplied this by this, it would make it squared, wouldn't it? It's the same thing. And then in order to get from x plus y back to 3x plus y, the only thing missing there was the 3. And then obviously I just didn't have these brackets in the middle, basically. I don't know if that kind of putting the brackets in makes more sense. I think someone else in the comments said they looked at it as a quadratic. So let me choose a different letter. Let's say you had 3n squared. No, hang on. N squared plus 3n. Let's say that. To factorize that, you would pull out n, wouldn't you, to have n plus 3? Now imagine that in this case, the n represents x plus y. Do you see how that would give me x plus y there, and then in the bracket x plus y? You could think about it that way if you wanted. There's two options there, I guess, whichever makes more sense to you. But yeah, it's an odd one, that one. I don't know, with 3 terms in the second bracket, it's kind of an odd one, isn't it? Yeah, okay. Question 15. Yeah, my issue with the trial and error is I just feel like it would take you too long. That's my only issue, and you might get the answer, or you might never get the answer. You know, there's so many different things to test out, so that's my only caution with trial and error. Okay, question 15, express 0.4 and then the 1/8 recurring as a fraction. So there's an actual specific method to this. So I always say, if they don't tell you, sometimes I say x is this, but if they don't, then I say let x equal whatever your decimal happens to be. Now, we want two versions of this equation where the recurring decimal is isolated, right? Do you see how the 4 is not recurring? So my first thing in this case is I want to move the 4 away from the decimal. So I'm going to multiply both sides by 10, which gives me 4 out of a decimal place, like it's now in the units, 0.18. Do you see how I've isolated the recurring part? So that's one version. I obviously can't use the x because it doesn't have just the recurring bit, so ignore the x from now. I then want another equation. I want 2. Now, not only does it need to isolate the recurring part, but it also needs to be in the same order. So I can't have like 8, 1 recurring. That's not the same thing, is it? So the next version, I'd have to multiply both sides by 100, wouldn't I? So 10 times 100 would be 1000x. And obviously this side by 100 would be 418. And then do you see how I'm now repeating the same recurring decimal, 18, 18, 18. So once you've done that, I've written it in that order because I'm now going to subtract. Yeah, you can either put 414 over 990 or the simplified version. They will accept either because they haven't told you to simplify it. So either one is fine. So subtract, obviously I get 990x on the left. This side, the whole point of getting and isolating the recurring parts is that when I subtract, they cancel. And then obviously don't forget to subtract the 4, right? So that'd be 414. And then obviously I want to now solve for x, because if I've started off with x being the recurring decimal, and then I've ended up with x being this fraction, then they must be the same, mustn't they? So you can either put this as your answer, or you can simplify it if you want. I think the most simplified is 23 out of 55, I think that was. That's the most simplified. They haven't told you to simplify it, so I probably wouldn't even waste your time, honestly. Yeah, I think you've divided it by 3, haven't you? They've said or equivalent, so any equivalent of that would be fine. Because they haven't said specifically to simplify it. Sometimes they do say give your answer as the simplest form, in which case you would have to, right? I don't go through AQA actually, I only go through Edexcel because that's the one I have the most kind of experience with, the most familiarity with. AQA I don't have as much of like a background in, so I feel like I don't really explain it very well. So yeah, sorry, I don't do AQA. I do Q&A sessions, so tomorrow at 5 o'clock will be a Q&A where you can just drop in and ask random questions. If you do have a, like a specific question from an AQA paper, I'd be happy to have a look at it. But I don't go through the whole paper. So we could do that. Yeah, I mean, obviously the syllabus is more or less 98% the same. I think I know that AQA has a lot of relative frequency, and I think Edexcel doesn't really mention that, but it's not really difficult. Anyway, mostly the syllabus is the same. It's just, yeah, as you said, the questions, the way they word them, the way they mark them is different, and that's why I'm saying about experience, because I have more experience with working through Edexcel, and when I read a question, I kind of know exactly what it means, and in my head, I'm quite aware of maybe what the mark scheme would say, whereas with AQA, I don't have that same kind of experience. So I think I would probably be almost double checking most of the time, which I don't know if that would help very much. I'm sure there's someone else who does AQA though that you can would have that experience that you could have a look at. Okay, so rationalize the denominator of 22 over root 11. So when it's one single surd or one single term, it's not plus or minus anything. All we have to do is multiply by that surd. Obviously it's a fraction, so the rules of fractions remain. You have to multiply the top and the bottom by the same thing. So at the top you'd get 22 root 11 over, obviously that would cancel and become 11. Now they've said give your answer in its simplest form, so you see how that would actually divide. You'd get 2 root 11. Obviously the 22 and the 11 at the bottom are whole numbers, so those would divide. The root 11 is not related to that, you have to leave it as root 11. Hexagon perimeter. I don't have access to the 2024 paper. It's not on the website. I don't know if you have like the question, like if you have a version of the question. If you could email me that, then I'd be happy to do a video on it. The only reason why I haven't been through 2024 yet is because they're still not released on the Edexcel website. I don't know if they're anywhere else though. They might be somewhere else. If you've got the like a link to it or something, then I could have a look at it for sure. So yeah, 2 root 11 for that first one, right? 2 root 11. Then we've got here, show that root 3 over 2 root 3 minus 1 can be written in this format. Now, obviously the main thing here is they've not said rationalize, but that's effectively what we're going to do, isn't it? Because you can see that this fraction doesn't have a surd in the denominator anymore, so we're going to rationalize. Now this is the one where I was saying about having two terms. It doesn't matter if they're both surds or if they're not both surds, but as long as there's two things, you see how I've got something plus or something minus something else. Yeah, if you've got them, you can send them to me via email. I don't know if my email's on the channel, but either way, it's basically the channel name, so GCSEMathsPro @gmail.com. Yeah, if you have like that particular question or anything, you can send it to me via email. Or if you know, well, you know the question you don't have it. Yeah, you can't access it exactly. I thought they used to release them 9 months later, but it's obviously been more than 9 months, so I don't know. I feel like they'll probably release them after your exams, which is not very helpful, is it? So yeah. But yeah, I would be happy to look at it if I had the question. So in this case, as I said, when you've got two terms, there's it's not quite as easy as the first one. In order to rationalize it, we are going to multiply by the whole denominator. The only thing you have to remember is that you have to change the symbol, because it kind of creates this difference of two squares scenario, and it will cancel everything out. So you have to change the symbol. Obviously, again, if you're multiplying something by the top, you have to do the same to the bottom of the fraction. So this is effectively the numerator's single brackets. You can write it, if you want to write it like this as single brackets, you can. If you want to multiply it straight away without doing that, that's fine. And obviously the denominator is double brackets, basically difference of two squares. If you know how that relates, then that will make it easier to expand. So expanding, just be really careful. What is a whole number? What is a surd? Because we can't mix them. So that's 2, the 2 is still just a whole number, isn't it? And then root 3 times root 3, which would cancel to become just 3, so 2 times 3. And then you have, obviously, root 3 times 1, so that's just root 3. That's the numerator. Obviously, you can then make that 6 at the end. Now, expanding the denominator, you can either expand it fully, or if you know what's going to happen because you know it's difference 2 squares, you can just kind of skip and expand it half. So 2 times 2 at the start would be 4, and then the root 3 times root 3, as we just said, would obviously cancel to become 3. I'm going to fully expand it just so you can see what happens, but you don't technically need to do this middle bit if you don't want to, because you know it should cancel out. Obviously, 1 times 2 root 3 is 2 root 3. Be careful of any positives and negatives, those are really important. Minus 1 times 2 root 3 is obviously minus 2 root 3. And then finally, again, be careful, the last number is always negative, so that'd be not just 1, but minus 1. Now, the whole point of doing that, changing the symbols, is because you see how this middle bit here, obviously when you add and subtract surds, they have to be the same surds, so I can actually add and subtract them. That would just cancel, wouldn't it? 2 root 3 minus 2 root 3 is 0. So that's the whole point. So you don't necessarily have to write that middle bit if you don't want to, if you know that it's going to obviously cancel out. And then obviously the other two terms are whole numbers anyway. So then we get 6, oh no, just 6 on its own, 6 plus root 3 over 12 minus 1, which is 11. Now, that's the format they've got. You see there's nothing in front of the root 3, so that's fine. There's nothing else I can simplify. So that is the answer. You got 1 out of 4. Did you, out of 4? There's only 3 marks, or 5 marks for the whole thing. Oh, you mean for the hexagon question? I'm just realizing we're talking about the hexagon question. Yeah. Okay, so that's just rationalizing, but just you have to know how to rationalize 2 different types of denominators, one that's got a single surd, one that's got 2 terms. Okay, question 17. So A and B are 2 similar cylindrical containers. This is the key thing here, similar. Surface area of container A to the surface area of container B is 4 to 9. This is kind of key numbers here, they've chosen those deliberately. Tyler fills container A with water. She then pours all the water into container B. Tyler repeats this and stops when container B is full of water. Work out the number of times that Tyler fills container A with water. So that's volume effectively, isn't it? Volume. So this is when you've got similar shapes and they're 3D shapes. It might be a cylinder, it might just be a random shape. I think I've seen some with like chess pieces, vases, like really random shapes that you wouldn't use a formula for, right? What we want is the ratio. So they've given you surface area. Think of surface area as just area. Area is, if we imagine centimeters squared, isn't it? Squared. Right? I'm trying to make it kind of, just think of area in the most basic sense. It's something squared. Do you see that's why they've chosen numbers here? 4 and 9 are square numbers. They've chosen those deliberately. So what I tend to do with this is I go, right, that's surface area, A to B, 4 to 9. Whether you're given the surface area to then find the volume. Sometimes you're given the volume to find the surface area, it doesn't matter. Just think of it, how can I make that into, imagine surface area is 2-dimensional, isn't it? 2D. Go, well, I want just one side length. Now I know that it's, ignore the fact that it's a cylinder, don't worry about the shape, just think of it as really basic. Side length, the length of something is 1-dimensional, isn't it? Centimeters. Technically to the power of 1, but obviously we don't write to the power of 1. So square root it is what I'm trying to say. Square root it, so that would be 2 to 3. So that's the ratio of like 1 dimension. Now in this case, because we're talking about water, filling it, that's the volume, isn't it? So then I need to find the volume. Now think of volume really, really straightforward, is centimeters cubed, which is 3-dimensional. So take your side lengths and cube them. So that would be 8 and 27. Just, you're working with square numbers and cube numbers. So just, that's how I do these questions. Just think of it as the most straightforward thing you can. Don't think about it, the shape, the type of shape. Don't worry about the formula for a cylinder. None of that. Don't worry about any of that. Just think of square rooting, cube rooting, or squaring, cubing, like that kind of thing. So the ratio of the volume of A to the volume of B is 8 to 27. Now, come back to the actual question. He's saying, so Tyler fills container A completely. She then pours it into B until the point where B is full. How many times would she have to fill up container A and effectively pour it into container B for it to be full. So do you see how I could just divide those? I know that doesn't divide equally, but effectively how many times would 8 go into 27? 3 point something, like 3 point something, isn't it? More than 3. So obviously then you would have to round it up to 4, wouldn't you? Because it's over 3. So in terms of the context, like, do you round up? Do you round down? You'd have to round up, wouldn't you? You could work it out exactly if you want, or you can do 8 times 3, 8 times 4, and realize which one is bigger than 27. So it goes into what, 3 times, and then it's a remainder of 3. You don't have to actually work this out, but just so you can see. 30 goes in 3 times, remainder 6, goes in 7 times, remainder 4, and then a 5. So that's 3.375. You don't technically have to work that out, but yeah, it rounds up, doesn't it? Because if she fills up container A 3 times, that wouldn't be enough to fill up B, would it? If she fills up container A 4 times, obviously that's too much, but that would still make sure that at least container B was full. She'd obviously have some left over, that's fine. So in the context, you'd then have to round it up to 4. Yeah, exactly. Hang on, let me go back. Oh, amazing, thanks. I can have a look at that, and I do have a Q&A session tomorrow. We could go through that hexagon question tomorrow. I'll have a look at it before then. Just checking what you said. The 81 over 16, I'm assuming that's... Yeah, they I don't know if that's relating to this or the hexagon question, but they will choose numbers, like when they do their ratio, if it's this topic, which is, you know, similar 3D shapes, something about surface area, something about volume, something about ratio, that topic, they will choose, especially if it's obviously, this is a non-calculated question, they will choose like square numbers, cube number, you know, numbers where it wouldn't be a decimal. Maybe I guess it could be harder if it was a calculated question, but in this case, they, you know, they've deliberately chosen 4 and 9. But yeah, no, to the power of 4 is not, like, volume is cubed, isn't. That's why I'm mentioning the units, because I feel like you're more likely to kind of recognize which units is area, side length, volume. It's just always that. It's always kind of some kind of square root or cube root, some kind of square or cube. Like, that's, yeah, it's quite hard to know what to do until you've seen that, I guess. But yeah, 4 for the answer and 4 marks. The hexagon is a proof question. Okay, yeah, I'll have a look at it and see if I can go through it tomorrow then. Yeah, I'll have a look at it overnight and see. Because I haven't seen the 2024 papers. Obviously, I don't, because I'm not a teacher. I don't have access, right? Yeah, and the one, whichever one you sent me via email, I'll have a look at tomorrow as well. Yeah, definitely, that's fine. We can have a look at that. We'll do those first before anyone else asks anything in the Q&A. That's fine. Okay, question 18, functions. I think for Edexcel as well, functions. Like when I went through all the past papers for paper 1, functions was quite a common question to come up in paper 1. I don't really know why. It could come up in paper 2 or 3, but it seems to be quite common in paper 1. I guess because it is just algebra, isn't it? So the function f is given by f of x is 2x cubed minus 4. They've then said show that the inverse function of f when x is 50 is equal to 3. So your answer should be 3 at the end, right? So first of all, we need to do the inverse function, and then we'll sub in x as 50. So normally I put y instead of f of x just to make it easier. You don't have to, really. Some people swap the x and y immediately. Some people swap it at the end. I swap it at the end. It doesn't matter, whichever you prefer. So I'm going to make x the subject. You can do this in one step if you want. You don't necessarily have to write it all out, but it's up to you. Obviously, then I would divide by 2. Just make sure you get the order of that. Dividing by 2 and then the cube root, you know, in the correct order. So then I get the cube root of y plus 4 over 2. Now, that equals x. So now obviously I'm going to swap it back, right? So we don't obviously want y in our answer, do we? That's not actually helpful. So swap it back if you haven't already. Plus 4. Yep. And now they've then said that x is 50. So sub that in. As I said, you don't have to write as much as I've written because I'm kind of running out of space, but just so you can see it. step by step. So 50 plus 4. Now this is the thing you have to work out. So 50 plus 4 is obviously 54, divided by 2 is 27. They won't make you, in non-calculator, square root or cube root anything that is not square or already a cube number, right? So obviously, in this case, I can cube root it. The live tomorrow is at 5 o'clock, as in the Q&A one. The drop-in session will run between 5 o'clock and maybe 6:30-ish, 6:45, because then at 7 o'clock I will start my paper 1 predicted paper that I've written. So the papers are always at 7 o'clock, but the Q&As are a bit random, but normally before that. So yeah, somewhere between 5 and 6:30 you can come and then we can look at your questions. So you should get 3. Obviously, well, they've obviously told you it's already 3, but 27, the cube root is 3. So you get 3. Now part B, yeah, we don't need part A anymore, do we? It's different functions. So the functions g and h are given by g of x is x plus 2, and then h of x is x squared. Find the values of x, so solve, effectively that means solve, for which the composite function h of g of x is equal to 3x squared plus x minus 1. So it's not saying that the composite function is this, it's saying that you need to work out the composite function and put it equal to 3x squared plus x minus 1. So this is just like a solving equations one, really. Obviously composite functions as well. Remember, composite functions always go in backwards, so that means I'm taking the whole of g and I'm going to put it in wherever there's an x in the h1. So obviously that's just squared, isn't it? So that would be x plus 2 squared. That's my composite function. And then I put that equal to 3x squared plus x minus 1. And then do you see how now I can forget about the functions? It's not even functions anymore. At this point, it's obviously just solving, which is another, you can see it's going to be another quadratic, isn't it? Hence why they've said values, multiple plural values of x. So obviously I'm going to expand this side. We get x squared plus, I'm just going to jump ahead, that's 2x and 2x, isn't it, which is 4x plus 4, 3x squared is the same. Now, the way that I decide which side to move them to, because obviously if it's a quadratic, you need to have everything on one side, 0 on the other, I decide whichever side would keep my x squared positive, so I'm going to move everything from the left to the right, because that would keep my x squared positive, because I'm going to try and factorize. And I don't really want to have to factorize a negative x squared. But I mean, you can, but I don't really want to. So minus x squared, minus 4x, so that's minus 3x, minus 4, which is minus 5. So that's what you should get as your quadratic. And again, we're factorizing again. Factorizing comes up all the time. This is now obviously a little bit harder because it's a 2x. 2x squared, not just x squared. So 2x and x. Luckily, it's 5, which is a prime number, so it's obviously going to be 5 and 1. You just have to figure out which side it goes in. 5 would be here, 1 is here, and also it's a plus and a minus, isn't it? So you have to figure that out as well. This one will be plus, this is minus. Solve it, so you should get, as I think someone said, you said in the marks, in the values of x, multiple. They haven't, like in this case, we wouldn't choose which one. It's just those are both the answers, aren't they? So I think my live is delayed by a good 30 seconds compared to what I'm actually saying. But yeah, so that's just quadratics really, isn't it, at that point? 6 marks in total, 4 marks for part B. Question 19, we've now got, obviously we would have negative and fractional powers at some point in paper 1. So given that 9 to the power of negative a half is equal to 27 to the power of 1/4 divided by 3 to the power of x plus 1, find the exact value of x. Yeah, you got the right answer, 0.75. So it's, I mean, it's quite hard if you don't know what to do, but if you've seen this before, because I have seen a couple of questions that's similar. In this case, they've used 3. I have seen them where they've used 2 as well, so you just have to recognize the numbers. But it's the same thing if you've seen that question multiple times. Do you see how 9 is a multiple of 3 and 27 is also a multiple of 3? So this is in terms of thinking, I know there's negative and fractional indices here, but I'm thinking in terms of index laws. Because when it says find the exact value of x, I need to create an equation. I know that's an equation, but I need to create an equation where x is in the equation, not as in a power. So what I want to do is get to a point at the end where I've got 3 to the power of something is equal to 3 to the power of something else, and then I would create an equation with just those powers, and that would be how I'd find x. So that's what I'm looking to get, which is why I try to recognize that those would all be multiples of 3. Sometimes, as I said, they might be multiples of 2. So 2, it could be 8, it could be 16, you know, things like that. It works in the same way. It's just obviously with a 2 instead of a 3. I guess they could do it from any number from 2 to 5, really, but probably 2 or 3. The other thing that made me realise that is because obviously I could work out 9 to the power of negative a half. I could work that out. But what I can't work out is 27 to the power of a quarter. Because as I said, they will not make you do any type of root that isn't already, like, they can't make you square root a number that is not a square number. They can't make you cube root a number that's not a cube number. This is technically mean, if you were to translate it into a root, it means the fourth root. I don't know what that is. That's obviously a decimal, isn't it? So they're not going to make you do that. So that's what made me also realise I don't need to actually work out the negative and fractional indices. In this case, I'm just going to use index laws. So what I did was I replaced the 9. How can I write that as 3? Well, technically 9 is 3 squared, and then that's still to the power of minus a half. Do you see how that's now an index law, isn't it? That's our third index law, where you multiply the powers. Same with 27. That's actually 3 cubed. We want to be able to recognise square numbers and cube numbers, so it's easier. And then to the power of, obviously, a quarter. And then the other 3 is fine, isn't it? It's already in terms of 3, so leave that. Now apply our index law. So I'm going to multiply that. So 2 times negative a half gives me negative 1, doesn't it? And again, I could work that out as a value, but I'm just going to leave it in terms of like powers. Just leave it like that. Don't actually work it out as a negative power. And then here, obviously, 3 times a quarter is 3 quarters. And then my last index law is this one here. When you have this divide symbol, you actually subtract the powers, don't you? Subtract the powers. So we got 3 quarters. Now, just be really careful, because not only am I subtracting x, I'm also subtracting the 1. Like, I'm subtracting all of that. So if I were to write it out, I would kind of write it like this with brackets, so that I remember to not only subtract the x, but also the minus, well, also subtract the 1. So just be really careful with that. They've done that deliberately. It's almost a trick question. So that would be, obviously, negative x, and then 3 quarters minus 1 is minus a quarter. So do you see how now I've got this scenario where I've just got 3 as a base number on both sides? It's the same base number, and there's only one of them, right? So 1, 3 here, 1, 3 here. If 3 to the power of minus 1 is equal to 3 to the power of something else, then surely those powers are also equal. So this is where I can now forget about the 3's and just go, right, here's my equation. Right, that's my equation. And now, because it said find the exact value of x, I just need to solve it. That's just a linear equation. So what I did was I added x to make it positive, added 1 to move that across. So as I think you mentioned in the comments, you can write it as 0.75, you can write it as 3 quarters. I just leave it as a fraction personally, but it's the same thing, isn't it? They said 3 quarters or any kind of equivalent. So yeah, 0.75 would be fine as well. But yeah, once you've seen how to do this, there are a couple of questions that Edexcel have done that are very similar. So again, it's just picking up on those patterns and having that experience that you've seen it before, and then it'll be much easier in the exam if you go, oh no, I've seen that before, I know how to do that. And obviously just apply it to whatever numbers they've given you. So yeah, kind of hard, but once you know what to do, I think it's just index laws, effectively. So that was 3 marks. Okay, we've got some graph transformations now for question 20. The graph of y equals f of x is shown on the grid. They've given you one set of coordinates, but you can see, you know, the exact points there as well. Part A, on the grid, draw the graph of with equation y equals f of x plus 1 in the brackets minus 3. Now, this one you just have to memorize what it means. It's obviously 2 transformations because we've got the plus 1 and the minus 3. So that's 2 things that are happening. And you just have to memorize what they mean, right? So you've said move down by 3. That's right. This bit on the outside, if it's on the outside, it's the y-axis, and it is the correct direction. So yeah, move down by 3. On the inside, it is the x-axis. Did I say that for the other one? The other one's y-axis. I don't know if I said x-axis. The other one's y-axis. This one on the inside is the x-axis. However, the thing I remembered when I did this was I just thought x-axis, there's always something wrong about it. What I mean by that is, I know it says plus 1. You're actually going to, actually, let me do my arrow the other way. You're actually going to go left. You're actually going to subtract 1. So you just have to remember with the x-axis transformations, normally there's something not quite right about it, basically. So we're going to go 1 to the left, 3 down. Now you can either draw it kind of one of them at a time and then draw the second one. In this case, because they're both translations, they're just moving around, I'm probably just gonna, just do them all in one. So I just pick out these, kind of a few exact points. This one at the end, 1 to the left, 3 down. This one here, 1 to the left, 3 down. This one down here, 1 to the left, 3 down, 1, 2, 3. This one here, 1 to the left, 3 down. Do you see what I mean? I'm just plotting some exact coordinates. You don't have to do all of them. 1 to the left, 3 down. There. Now I can obviously join it up with my line. Yeah, part B is relating to why they've given us the coordinates for A. There we go. Obviously don't do it in pink in real life, but that's fine. That's basically your answer to part A, 2 marks. Just memorize the transformations and then they're actually quite easy once you've got them memorized. Okay, part B, I need to be able to see the graph, I guess. So point A, minus 2, 1, which you can see was up here. Don't know if you can still see that. Lies on the graph of y equals f of x. So the original, right? We're talking about the original one, not the one we've just drawn. When the graph of y equals f of x, again, the original. Yeah, just be careful that there are. You could write it as vectors if you wanted. It's like column vector, it'd be like this, wouldn't it? You could write it like that if that helps, but yeah. So when the graph of y equals f of x is transformed to the graph with equation y equals f of minus x, point A is obviously mapped onto point B. Write down the coordinates of point B. So again, you just have to memorize what that transformation means. There's no numbers, so it's obviously a reflection, but where is it reflecting? It's next to the x, so it's actually a reflection in the y-axis because all the x coordinates are changing, basically. However you want to memorize that. So we're reflecting, our mirror line is here, isn't it, vertically? So that one would go across, and it's effectively where I've drawn this other thing, isn't it? All the x coordinates would change symbols. That would become, like, that's here, isn't it? That would be point B. So it'd be 2, 1. Obviously the y-axis coordinate is still the same, it's not changed, because it's only one transformation, it's only affecting one of the coordinates. So 2, positive 1. Yeah. Oh, you said minus 2, minus 1. Oh, because you reflected it down. I think you reflected it down here, right? It's because it's next to the x coordinates are changing, which means it's a reflection in the y-axis, if that makes sense. It's quite hard to get your head around it. Either memorize it as, the way that I memorized it when I was doing this was, for reflections, I just memorized it as it's the opposite. So if it's next to the x, it means y-axis is the reflection. If it's not next to the x, if it's kind of on the outside and closer to the y, it means it's the x-axis reflection. Or you can memorize it as it's next to the x, which means the x coordinates are changing. Now, if the x coordinates change, then it reflects horizontally, doesn't it, which is the y-axis. So whichever of those two things, yeah, whichever of those two you want to memorize, whichever method makes more sense to you. I just memorized it as the wrong way around. Whichever way around I thought it was the other way around. So that's how I remembered it. You can memorize it however you want. But effectively, you're making the x coordinates negative. Now, if it's already in negative 2, if I make it negative again, it becomes a positive, doesn't it? It's like a double negative. So yeah, however you want to memorize it, but just for graph transformations, they're quite easy as long as you have memorized them. That's the thing. You just have to the problem is memorizing it is quite hard. That bit. So yeah. Okay, question 21. This is quite a big question. I think this is a 5 marker, this one. Obviously we're getting towards the end. Yeah, 5 marks. So quite a lot to do here. Sketch the graph of y equals 2x squared minus 8x minus 5. Now, obviously that's a quadratic, and you first of all need to know that the quadratic, positive quadratic, is a U-shape. That's the first thing you need to know. It's going to be some kind of U-shape. And then showing the coordinates of the turning point. Yep, you've said in the comments, that means you ever see turning point and a quadratic, and you can't obviously see the graph, it means completing the square. You just have to make, put 2 and 2 together, completing the square. And the exact coordinates of any intercepts with the coordinate axes. That's not only, obviously we know normally, most of the time, a quadratic will cross through the x-axis twice. Normally, depends if it's moved up, but it hasn't. It's moved down, isn't it? So it will cross through the x-axis twice, so there's 2 coordinates there, but also it will cross obviously through the y-axis, so that's the 3rd coordinate. So effectively you need 4 sets of coordinates. You can do them in any order, it doesn't really matter. Now they have said exact coordinates. Now when they say the word exact, it kind of makes me think that there's probably decimals involved, and given that this is a non-calculator, I obviously won't be working out the decimal, so I'm assuming it's probably some kind of square root. You know, it says exact, you leave it in terms of a surd. That's kind of the hint that's telling me, which also tells me that I probably can't factorize. Normally I would factorize, but I feel like I probably can't in this case. The first coordinate that I did was the one where it goes through the y-axis, the y-intercept. That one's really easy. The same with straight lines. You know when you have a straight line and it's y equals mx plus c? The plus c, the number at the end, is always the y-intercept. It works the same for a quadratic, because obviously if you subbed in 0 for x, all of these would cancel to make 0, and then the only thing left is the only number that doesn't have an x. So that one I just basically was like, yeah, okay. That's obviously my y-intercept at -5. That one's pretty straightforward. So I just wrote it here. Now, I'm going to complete the square first, obviously to create the turning point, but I think I'm going to solve it by completing the square as well. You could solve it by doing quadratic formula, but I'm going to use completing the square because I have to complete the square anyway. So completing the square, y equals now. This one's obviously harder because it's a 2x squared, so I'm going to pull out the 2. Some people pull out that coefficient from all 3 terms. I don't like to do that. I like to just pull it out of the first 2 because it's not really relevant to the 3rd term, and also a lot of the time the 3rd term is not a multiple, in this case of 2, so I don't really want decimals. So I'm just going to literally factorize it out of the first 2. You can do that. You can partially factorize anything you want. Leave the 5 at the end, just deal with that at the end. Now I can complete the square in these brackets. So that would be x minus 2 squared. You always subtract the number in the brackets squared. So technically that's subtracting -2 squared, which obviously, just be careful with the negatives. -2 squared becomes +4, but I'm still subtracting it, so I'm taking away 4. -5. Now we're going to expand the 2 on the outside, so just put 2x minus 2 squared, and then obviously you have to times the 2 by the 4, so that'd be -8 minus 5, and then finally you can add those 2 together. When I say add, I mean obviously in this case subtract, right? So -8 minus another 5 is -13. So I've completed the square. So my turning point coordinates derive from here, don't they? The only thing is, again, think about your graph transformations. We're changing the x one. So turning point, I'll just put TP, right? TP for turning point is +2, and then the one on the outside is the y-axis, which is the same, just -13. So that's my turning point. Now I'm missing 2 coordinates, which is when I want to find where they cross the x-axis. So that's when y is 0, isn't it? So I just made this 0 and I solved it because I don't think you can factorize. Otherwise I probably would factorize, but I'm just going to solve it this way. You can solve it however you want. I don't think you can factorize, so either use completing the square or the quadratic formula. But either way, I don't think you can work out the square root, right? So what I would do in this case is obviously add 13. Divide by 2, so you can either put 6.5, I'm just going to leave it as 13 over 2. And then we need to square root. Now don't forget, when you square root, you get 2 answers, plus or minus. That's where our 2 solutions will come from. Plus or minus root 13 over 2. And then the last thing is to add the 2, isn't it? So do you see where I'm going to cross the x-axis? My coordinates for x is either 2 plus root 13 over 2 or 2 minus. You got actual nice numbers, like 4.5 and -0.5 is quite nice numbers, aren't they? But it's not in this case. And obviously I'm not going to work out the root 13 over 2, right? They won't make you work that out, so leave it. That's why they said, when they say the word exact, oh, why is it zooming in? They said the word exact, that normally implies to me that it's probably, whether it's a fraction or more likely in this context, going to be a square root, like leave it as a surd. That's what I would do. So I'm not obviously going to work out what is root 13 over 2 because I would not even know where to begin with that. So now I've got my coordinates. So the other one was 2 plus root 13 over 2. Obviously then y is 0. And then 2 minus root 13 over 2. You don't have to work that out as a decimal, don't worry. So I've got my 4 coordinates. Now I can actually just sketch it. So I think you just basically, if I try and move this over a bit, get some, you know, get a ruler, draw. I don't think, oh, why is it still pink? It didn't give us any graph paper, so it's not accurate, right? It's just a little sketch, basically. So I'm going to get my axes, you know, something like this. And then roughly plot them out. Obviously, as long as you draw them on, then they'll know it doesn't really matter if it's not necessarily to scale. So let's say, I don't know, well, do you know what? I'm probably going to just draw. I might just draw the U shape first. I know that the U shape is going to be something like this. Because I know that, so that's -5, isn't it? My turning point I know is lower than that because it's -13. So I'd probably put, you know, 2 minus 13 there. And then naturally, you obviously then end up with it crossing negative and crossing positive. So this one would obviously be the bigger one, right? The 2 plus. So 2 plus root 13 over 2. And then this one's obviously then had to be the -1. So 2 minus root 13 over 2. So see how I don't have to actually work out 13 over 2. I'm not actually working that out. Yeah, that you can work it out as an estimate, but you see that they won't I don't think they would accept that because they said exact coordinates. They didn't say an estimate, so I wouldn't estimate it. Because they want the exact coordinates. They don't want like a rounded version, if you see what I'm saying. That's why they mentioned exact. I can check. They have said or equivalent, but the thing is, if you've done an estimate, it wouldn't be the equivalent, would it? So I don't think they would allow that. I'll show you the mark scheme. You see here, turning point 2 minus 13, so that is just nice numbers. The intercept 0 minus 5, that one's quite nice. But then you see how they've literally left it like that. You could obviously put 6.5 if you want, as in root 6.5, but they haven't actually, they haven't expected you to work it out. And they've said here, or equivalent. So as long as it's a literal exact equivalent, but if you estimate it, it wouldn't be an equivalent. It would be like roughly. So yeah, I'm not sure if they would allow that. Just because of the fact that they did mention in the question it had to be exact. That's the only reason I'm saying that. So yeah, some kind of U shape, and as long as you've marked on all these 4 coordinates, then that's fine for the 5 marks. Okay, question 22. I think this one we actually looked up in our, I think we went through this in our, oh, this is the last question. We went through this in our Q&A session the other day, actually, because we were looking at congruent triangles and shapes and things like that. But this one's, I don't know, it's not a very nice one because circle theorems in the first place not very nice, and then overlapping it with proof even less. Yeah, I feel like you've done more work but then lost a mark for it. So yeah, I would recommend, like I said, they're not going to make you square root anything you don't need to square root, like that you can't square. They won't make you do that. I know for Edexcel, I can't speak for other, maybe I'm assuming AQA is the same. I don't know about international ones, things like that. But in terms of normal Edexcel, they're not going to make you square root or cube root anything that is not already square or cube number unless you have a calculator, which we obviously don't, do we, in this case? So yeah, I wouldn't even try and square root anything if you don't have to. Okay, so A, B, C, and D are 4 points on a circle, as you can see. A, E, C, and D, E, B are straight lines. So these cross, like the ones that cross, they're straight lines. Or more specifically, chords, I guess. Triangle AED is an equilateral triangle. So like that's the same as that, which is the same as that. Prove that triangle ABC is congruent to triangle DCB. So I'm going to just quickly map them on so you can see which ones they are. So it's kind of hard to, there's just so many lines otherwise. This one. That one there is congruent. Now if I just pick another colour. To this one here. I think from looking at it, there's loads of different ways to do it. So the way that I picked out, you might have done a different method. So that's fine. Like we might not have the exact same method. So don't worry about that. Yeah, it's a cyclic quadrilateral, that's true. Oh, no, you can use circle theorems, but there's only really one circle theorem I would have used. It's not like multiple circle theorems. You can use circle theorems, yeah. Because otherwise what would be the point in it being in a circle? So, okay, so congruent means that they are literally identical. I know that one's like flipped, like it's reflected, isn't it? But in terms of if you were to kind of like overlay them on each other, they would have all the same angles and all the same side lengths. So like they're literally a carbon copy of each other, just obviously one has been like flipped, if that makes sense. So they're exactly the same. So you can use, yeah, you can use circle theorems. Otherwise, yeah, I don't know. If they didn't want you to use circle theorems, I don't know why they would put it in a circle, I guess, is what I would say. So the topic of being congruent triangles, you can prove it. You have to prove that three things are the same. It depends on the question as to which three. So it could be angle, side, angle. It could be a side, an angle, and a side. Obviously, they have to, if you do angle, side, angle, it has to be an angle, then the side between it, and then the other angle, right? It can't just be random. Again, same with side, angle, side, has to be the angle between the two sides. I think you can also do angle, angle, side. So those are like an angle, a different angle, and then a side next to it. I think that's fine. And if you have a right angle triangle, you can do right angle, hypotenuse, side. Also, I think those are the main four. You can't do three angles because technically you could have triangles that have the same three angles, but one is bigger in terms of side length. So you can't do that. That would just prove they're similar. Okay, so we're going to basically one of these. I think from looking at the mark scheme, there was multiple ways to do, like they've given 4 or 5 different ways to do it. So if you do it differently to me, that's fine. As long as you obviously prove one of these. The first thing that I thought, which is probably the most obvious, is that BC is the same as BC, and like they both share the same side. So that I thought was, if you didn't know how to answer this properly, you could at least get 1 mark just for writing the fact that they both have BC in common, and you've not really even done anything, right? So that was my kind of starting point. BC, and I put like common in both, or in both triangles, or shared, or however you want to write that. It's the same thing. AAS and ASA is the same thing in terms of the fact that it's 2 angles and a side, but it's not the same thing in the fact that the order that they are in, if that makes sense. So let me get a different. Let's say, so ASA, let's say, just for example, this is obviously not necessarily accurate, but for example, angle, side angle could be like this angle, and you see how it's the side between them? Whereas angle, angle, side could be this angle, and then that side. So that's the only difference, but it is still 2 angles and a side, right? Yeah. I think there's 3 of these. Yeah, you could prove any of these in this case. Obviously not the right angle one because there's no right angles, but in this case you could have proved any of these 3. I went with the last one, just personally. So I said, right, there's a side in common in both. Obviously all of these have a side anyway, that's fine. I then went with kind of like a low-hanging fruit, I would say, like a really easy one. As I said, using circle theorems. The one where it's angles in the same segment are equal? So this one and this one, which are in the triangles, they are in the same segment. Do you see how they both stem from B and C? So I said then CDB, or however you want to write it, is equal to CAB. And then you write the reason, like angles in the same segment are equal. That's what I put. So all I need to do now is prove one more thing, which I think is then harder. Also, you can see in my case, the side is over here, the angle's over here. They're not relating, so that's probably why I'm gonna go with this one. So what else did I prove from here? Yeah, because we haven't used you've mentioned 60-degree angle. We haven't used the equilateral triangle yet, which you can use it in multiple different ways. What did I prove? Which one? I'm just having a look at my working because this was so many different letters. I think I proved these 2 angles here. I think I proved this angle was the same as this one, which touches the side. I think that's what I proved, if I'm trying to look at this correctly. ABC, yeah. DCB. Yeah, I proved that, but it's kind of multiple steps to it. ABE. What was we saying anyway? ABE and DEs. Oh, you mean these two? Yeah, those would be the same as each other, but those aren't angles in the triangle, if that makes sense. Same as like this angle would be the same as that angle, vertically opposite, so you can use that. Obviously, we know that in our equilateral triangle, they're all 60, AC, A to C. Yeah, so that's what I was kind of linking. So I think I said, obviously that's 60 because all of these three are 60 because it's equilateral, right? And then I think I said, what am I saying? A, B, E. I want to visualize it. E, C, D. I can't even figure out what I've said, but I think what I was saying was like if we look at it from a different direction, like obviously in real life you can kind of rotate your paper if that's helpful for circle theorems. I always recommend that. We could do angles in the same segment again. So you've said that ACB is 60 because of that, because of the angles in the same segment. But if you look at it like from A to D to B, I think that's what I was meant to write down. That one is 60 because we know it's an equilateral triangle. But then if you do the same segment, so coming from A still, coming from B, that angle must be the same, mustn't it? So that's also 60 in there. This little bit, right? This small bit here, that's also 60. Now, we also know that that's 60. We know that therefore that's it. This is basically an equilateral triangle, this small one, isn't it, as well? You can also figure that out. That's also an equilateral triangle. I know that some people use that to prove the sides were the same. You could do that. So I think I got that was 60. ACB is the same as, yeah, 60. And then I figured out this was the same. How did I do that? I actually wrote this down and I don't know why. I'm trying to read what I've written. A to B to E is equal to E to C to D. Oh, I think I meant to write D, that's why. Just recorrect my working if I look at this ever again. I was thinking, how is E the same segment if it's in the middle of the circle, but I meant to extend it to D. So A to B to D, A, B, D. Let me get rid of my, yeah. And then A to C to D, there we go, that makes more sense. Why have I written that? Also, angles in the same segment, isn't it? There's too many things to, I'm going to have to get a different colour now. So what I'm saying is this angle is the same as this angle, and you know how we proved that both of these are 60, that's 60 and that's 60, and then the what's that, like teal colour, they're also the same because of angles in the same segment. So then when you put 60 and the teal colour together, that is actually an angle. I know you can barely see it anymore because I've drawn so much on it. That is an angle in the segment, in the triangle, isn't it? Let me try and see if I can, oh, that's the whole thing. I just want to get rid of this highlighter so we can actually see what's going on. Delete this. Yeah, I found this one quite hard. I feel like you could probably get an angle and a side quite easily, but it's like that third one that I think is a little bit harder. I don't know if that makes sense. Let me write it out. So it's because it's kind of like 2 steps to prove one angle's the same. So I've said, I'll do it in that colour so you can see which bit I'm referring to. I've said that, what was it, ACD is the same as ABD. Yeah, there we go. Because of the same reason, we're just using angles in the same segment like a million times. And that's part of one of the angles in the triangle, isn't it? And then the other reason was that angle ACB is the same as angle ADB, again, oh, where's my equals, which is specifically 60, because of the equilateral triangle and because of the exact same reason the angles in the same segment are equal. So I'll put a little kind of thing there. And equilateral triangle. So then therefore, let me scroll this down. Therefore, those two angles together make the actual angle in the triangle as a whole, isn't it? What's that? BCD and ABC. Therefore, they are the same. That's just implied. Now, I've got three things there, right? As in, my three things in terms of the triangles is the side, this angle, and these angles. Those are my three things, right? And you see how I got so I put therefore congruent, just write, means they're congruent, and you can just write the acronym, you don't even have to write it out fully. I did AAS because I've got this random angle over here, then I've got an angle and a side. That's the one that I got. You could have got any of the other three, so any of the three, so ASA, you could have got SAS, or the one that I did. If you look at the mark scheme, there's like 5 different options. So you might not have done it the same as me, but as long as you've proved that 3 things are the same, including, you know, a mixture of angles and sides, then I'm sure that would be fine. But yeah, 4 marks. That was a hard question. I didn't personally like that question very much, to be honest. But I think you could get definitely 1 mark for writing BC isn't common in both, even if you didn't know what else to do after that. That's still 1 mark. Like, you literally still get 1 mark for just writing the fact they both have BC. So if you're not sure what to do, just write anything. That might even get you a mark. Okay, let me have a look what you said. 2022 paper 1 June, the last question. So yeah, I can have a look at that. Iteration, I don't think iteration would come up in paper 1. The reason being is because iteration is normally like 5, 6, 7, 8 decimal places, isn't it? Normally. So I don't think they would do that because, yeah, you wouldn't be able to work out that many decimal places. I think you could probably make a safe bet that iteration would either be paper 2 or paper 3. Calculator, yeah. I really, really don't think, I've not seen it at all come up in any of the past papers for paper 1. I think the numbers are just too complicated. So yeah, that's not many of them you can kind of assign to a paper, but I think that is one that you could probably say is calculator only. Obviously don't rely on me saying this because if it does come up, but I really don't think it would. I think it would be too difficult. And if it did, it would be like a really easy formula, like a super easy formula if it did. Obviously it wouldn't be like loads of decimals, right? Okay, yeah, we can quickly look at that other question if you want. Hang on, June 2022, paper 1. Last questions. The 5 marker. See. Literally the question 21, the last question with the circles. Yeah, the rest of them aren't 5 marks. Yeah, that one I actually have a video on that. I can go through it if you want, but I also do have a video where I've like actually edited it together because I listed that under what topic was this? Trigonometry. It's on my video the video called hardest Edexcel trigonometry questions. It's one of the questions there. This is also another one where you could do it a few different ways, I think. So yeah, it's on that video if you want to look at it. I don't know if you want me to talk through it now, so you can ask questions, or if you're fine to just have a look at the video. Yeah, I feel like there's always 1 or 2 what I'd call wildcard questions that don't necessarily follow a pattern and are like just really hard to figure out, and this is definitely one of them. And by the sounds of it, I guess that hexagon one was also. I've not seen it, but yeah, it sounds like it. There's always kind of 1 or maybe 2 questions throughout all 3 papers where at the end, 5 marks, they're like just really random questions, not anything you might have seen before, and it's quite hard to figure it out. It's just a lot of logic, which I think is quite hard to figure out. Yeah, this one is a really big question to follow along the logic for. There's so many different moving pieces. Yeah, it's hard to start. I mean, what were they asking? They gave you circles, but it's also like then you're probably thinking, well, how do I do trigonometry within circles? Like, yeah, there's also triangles within circle sectors and everything. Oh yeah, my predicted paper, I haven't actually uploaded it yet. I'm gonna go through it tomorrow in the live, but what I'll do is I will link it in the description of that live. What I will also do is I've filmed a video on it, walking through it. So that will be edited and that video will upload on Monday, but I will walk through it kind of with you tomorrow if you want to join me tomorrow. Obviously that live will also upload itself anyway after tomorrow. So I'll probably link it in the description to that one. I guess I might have to link it as a Google Doc, I'm not really sure. I think so. But yeah, I also need to write the answers down as well, actually. But yeah, I can link you the video for the trig one. Or you can obviously find it on my channel, but it's, where is it? Hardest trig. I've got like a whole series of kind of hardest questions, but obviously in different topics. Let me just put it in the chat. Give me a sec. I don't have a website right now. I mean, because I'm just starting, but I was going to build one eventually, like next year, but obviously it's not massively helpful for you guys for this year. So it's just all on my channel, basically. It's literally everything's just on the channel. Where's the chat? There we go. This is the hardest. Can I spell? That would be great. There. So that's some of the other hardest ones as well. There's some kind of similar ones. Which question was it? The questions are listed in the description, right? So it's got chapters and everything. Let me just see which question it was. That's also got the one on bearings. I don't know if you know this, a bearings one as well with trig. Wait, where is it? Is it here? Saying that, but I don't see it. Wait. Oh no, yeah. Question two. So if you kind of skip through the chapters, what do they call it? You can go to question 2. When does question 2 start? About 11 minutes in, 11 and a half minutes in. That's that exact question. So you can watch that and go through it there. Yeah. Yeah, sorry I don't have a website, but yeah, feel free to email me. We'll go through your question tomorrow, the one that you've emailed me. I'll have a look at it and prepare for tomorrow. We'll go through that in the Q&A, okay? And the hexagon question as well. And yeah, perfect. Thanks guys for joining me today. Again, if you have any questions, please leave them down below as a comment. As I said, you can also email me if you've got any other questions. But otherwise, I will see you tomorrow.